Welcome back. Till long day after, today I will discuss some important examples of metric space. Which of the following be a metric space and which of the following be not metric space? Actually, this type of example very important for all competitive exam, also for higher study. And today I will discuss this part again because this time is actually the exam time. All exam has announced this month. So I have discussed few questions just as a review. First question. Which of the following define a metric on R? Option 1. d1 xy equal to absolute value of mod x minus absolute value of mod y over 1 plus mod x times mod y. Second, d2 xy equal to square root of x square minus y square. Third, d3 xy equal to absolute value of fx minus f of y, where f be a function which is defined from R to R, which is strictly increasing function. And fourth, d4 xy equal to d1 xy plus d3 xy. First, I will tell you, just try to own self. This type of example actually very easy type question. First example, we all of us know metric over 1 plus metric. This is always be metric space. This part is dp. Consider this is one metric who is denoted as dpxy equal to absolute value of mod x minus absolute value of mod y. Obviously, dpxy always greater than 0, and when dpxy equal to 0, that means obviously absolute value of mod x minus absolute value of mod y equal to 0, and this imply obviously x equal to y, and this is if and only if condition. That means first two property would be satisfied. Then symmetric property also would be satisfied. dpxy always equal to dpyx. And the last property, triangle inequality, also would be satisfied because absolute value of mod x minus absolute value of mod z always less than equal to absolute value of mod x minus absolute value of mod y plus absolute value of mod y minus absolute value of mod z, and this is equal to actually dpxy, and this is equal to dpyz. That means dp and this part means dpxz less than equal to dpxy plus dpyz. Therefore, triangle inequality also be satisfied. And since all condition of metric space has satisfied, so this dpxy be a metric space. Next, consider this part. Consider this part is denoted as dqxy equal to absolute value of x times absolute value of y. Obviously, this is be a metric. Just try to oneself. This is very easy part. And since this is be a metric and this is be a metric, so for 1 plus metric be a metric space always. I hope my all viewers have understood why this is be a metric space. Because metric over 1 plus metric always be metric space. Option 2, d2xy equal to square root of absolute value of x square minus y square. Is it metric space? No. And why not? Just think on self at first, then see my video. Why not? Because in metric property, d2xy equal to 0 means x equal to y, and this is the if and only if condition. If we consider 2.1 and minus 1, then obviously d2xy would be equal to 0, because here square root of absolute value of x square minus y square. But notice here x not equal to y. So option 2 is a wrong option. And option 3 imply d3xy equal to absolute value of fx minus f of y, where f is strictly increasing function. Is it metric space? Obviously this is metric space, because this is very easy type. Here given f is strictly increasing function. But d3xy equal to absolute value of fx minus fy. And here also indicate f, which is defined from real number to real number, is strictly increasing function. Obviously d3 be a metric space, because d3xy equal to fxy minus fy, obviously this type of function be a metric space. Also here given f is strictly increasing function. So since f is strictly increasing function, obviously f is 1 function, and 1 means if fx equal to f of y, then that implies x equal to y. That means d3xy equal to 0, that means absolute value of fx minus f of y equal to 0, and absolute value of fx minus f of y equal to 0 imply fx equal to f of y, and since fx equal to f of y and given f is strictly increasing function, so by the property of 1 that imply x equal to y, and this condition is if and only if condition. That means second property of metric space, d3xy equal to 0 imply x equal to y. This is also true, and obviously this type of function greater than 0, and d3xy equal to obviously d3yx. This is always symmetric, and this type of function always satisfy the triangle inequality. d3xz would be less than equal to d3xy plus d3yz. So d3xy equal to fx minus absolute value of fx minus f of y. Obviously always metric space. Fourth, 4xy equal to d1xy plus d3xy. This is also be a metric space, because I have seen this is be a metric space, this be a metric space, and we all of us know sum of two metric space always be metric space. So option 4 also be a metric space. I hope my all viewers have understood this type of concept. Actually I have defined in my previous video. If you don't see my previous video, at first see my previous video, then you will understand this part easily. Just see the playlist of metric space. Okay? Our next example. Now I will see one question which had come GATE 2021 exam. The question is, consider the following statement. Here the first metric d1xy equal to mod log xy. First question, is this function is a metric on the open interval 0, 1? Option 2, d2xy equal to mod x must plus mod y if x not equal to y, and 0 if x equal to y. Is it metric on the open interval 0, 1? And option 1 indicate P is false and Q is true. Option 2 indicate P is true and Q is false. Option 3 indicate both P and Q are false. And option 4 indicate P and Q are true. For this, notice this is the graph of log x. Here d1xy equal to absolute value of log x over y. Notice log function is defined on the open interval 0, 1. So this is obviously defined, and when the value of x over y less than 1, that imply obviously log of x over y less than 1, but here the absolute value. So obviously since here given the absolute of log of x over y, that means when x over y less than 1, that means obviously d1xy greater than 0, because here absolute value means our first condition has satisfied. d1xy always greater than equal to 0. Second condition, second, d1xy equal to absolute value of log x over y. We can write this as, since here absolute value, we can write this as minus log of x over y. Obviously this value and this value is same. Then this is equal to absolute value of log x over y. Here we can write this power as inverse, because by the property of log, this means this, and this means actually absolute value of log y over x, and this is actually d1 yx. That means d1 xy imply d1 yx. That means symmetric property also has satisfied. Third property, and when d1xy equal to 0, that means absolute value of log xy equal to 0. That means obviously since here that imply log of xy equal to 0, x over y equal to 0, and the value of 0 means obviously this is log same as log 1, because we all of us know log 1 equal to 0. That means log x over y equal to log of 1, and log 1, but the value of log 1 is 0, and by this expression this imply x over y equal to 1, that means x equal to y. That means when d1xy equal to 0, that imply x equal to y. Therefore third condition of metric space also has satisfied. For the triangle inequality, means we have to prove d1xy less than equal to d1xz plus d1zy, and d1xy means obviously mod log x over y, and we can write this as log x over y means obviously log x minus log y. We can add log z also minus log minus z, and by this expression we can write this as, this is log x minus log z, and this is log z minus log y, and consider this part is a and this part is b. That means absolute value of a plus b, and by triangle inequality we all of us know absolute value of a plus b less than equal to absolute value of a plus absolute value of b. That means this is less than equal to absolute value of log x minus log z plus log z minus log y. Okay? Therefore this means d1 xz and this means d1 zy. Therefore d1 xy less than equal to d1 xz plus d1 zy. Therefore, triangle inequality also has satisfied. So, all condition of metric space also be satisfied for this function log x over y. So, obviously, this part is right option. d1 xy is a metric on the open interval 0, 1. Now, I will say, is d2 is metric on the open interval 0, 1, where d2 is defined as mod x plus mod y if x not equal to y and 0 if x equal to y. Obviously, d2xy be a metric space, and this is very easy to prove. At first, try to ownself, then see my solution. Let's see the solution. For xy belongs to R, clearly mod x always greater than 0 and mod y always greater than 0. That means their sum obviously greater than equal to 0. So, by definition, d of xy greater than equal to 0 for all xy belongs to R. Second, for xy belongs to R and if x equal to y, then that imply d of xy equal to 0. This is the given condition. When x equal to y, then d of xy equal to 0. Now consider, since this is if and only if condition, now consider d of xy equal to 0. And when d of xy equal to 0, then that implies x equal to 0, x equal to y. That means second condition also be satisfied. And if x not equal to y, then that implies d of xy equal to mod x plus mod y. And d of xy equal to 0 means mod x plus mod y equal to 0. And mod x plus mod y equal to 0, that implies mod x equal to 0 and mod y equal to 0. And when mod x equal to 0, that means x equal to 0, y equal to 0. That means x equal to y. So, I have considered x not equal to y. Here I have got x equal to y. That means our assumption is wrong assumption. When d of xy equal to 0, then that implies x not equal to y. This is not possible. Right. Symmetric condition also would be satisfied because here d of xy means this. We can interchange this as 0 when y equal to x and mod y plus mod x when y not equal to x. Just interchange this method, and when we will interchange this part, then this is equal to d of yx. That means d of xy equal to d of yx. That means symmetric property also be satisfied. Thing noticeable. Here the second metric space denoted as d2xy, but I have written as dxy, not here d, here d2. All part would be d2, here also d2, d2, here d2, here would be d2. That means d2xy equal to d2yx. Okay. Next, I will say the triangle inequality. This is also satisfy the triangle inequality because they consider x equal to y and y not equal to z. Then d of xz means mod x plus mod z, and since x equal to y, so this is mod y plus mod z. Now just add 0, and 0 means obviously this is, since x equal to y, this is d of xy, and sorry, here d2, d2, and here absolute value of y plus absolute value of z means d2yz. Therefore, d2xz equal to d2xy plus d2yz. Okay. For when x equal to z and z not equal to y, then since x equal to z, then d2xz equal to 0, and obviously 0 less than mod x plus mod y plus mod y plus mod z, and mod x plus mod y means d2xy and mod y plus mod z means d2yz. Therefore, d2xz less than sorry, this dt is less than d2xy plus d2yz. Therefore, triangle inequality also be satisfied when x equal to z, z not equal to y. Fourth, consider x, y, z both are different. Fourth, consider x, y, z both are different. And obviously d2xz means mod x plus mod z, and this is obviously less than equal to if we add mod y plus mod y. Obviously this would be less than equal to, because here I have added extra term also, and this part is d2xy and this part is d2yz. Therefore, d2xz less than equal to d2xy plus d2yz. That means triangle inequality also be satisfied here. So, d2xy also be metric space. That means both p and q are true. d1xy and d2xy both be metric space on the open interval 0, 1. I hope my all viewers have understood. I will stop here. In my next video, I will discuss some more example of metric space, because this type of example actually very important for any competitive exam. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.